So let's start. So let's start with this week's this week's tutorial. So the first thing is that I hope all of you have already installed Proteus software in your computers, right? So the first thing is to launch the Proteus software, right? So if you launch the software, you'll get the interface something like this, right? So what you need to do is to create a new project, right? So you create a new project. So you can name it. So in our case, we'll just name it as an example Proteus project, right? And you can define the destination of that, right? So we'll save it on our desktop here. And then what you just need to do is to click next, right? Once you have that, just click next. You'll get something like this. Again, just click next. We don't need to create any PCB, right? We are just involved in doing the simulation. So next again, we are not dealing with any firmware project. Again, just click next, right? Whatever you get, just click next on it, right? Once you're ready, you'll get a screen like this, right? So like I said, in this week's, for this particular tutorial, I'll be just showing you how to use a PIC microcontroller, how to perform a microcontroller simulation in Proteus, right? How you can turn on and off a LED, and also how you can interface components with the microcontroller, right? So the first thing is that let's say we'll just perform a simple simulation for lighting a LED for 1 second and turning it off, right? So first thing is to go in the components section, right? Component mode. Click on component mode, just in case if it's not in component mode, click on component mode, and then click on P. P stands for part list, right? While L stands for library, right? So we don't have to do anything with the library right now. Just click on the part and search for the parts that you need, right? So in our case, we'll need a microcontroller that is 18F8722. So that is what I'm going to search, because that is the microcontroller we are using in our projects and labs, right? So we'll use that. So I'll just click on that, right? Okay. Again, I'll search for the next part. We are going to light a LED, so we'll need a LED, right? So let's search for an LED. So we get a list of LEDs here. So we'll just go and look for a red LED, right? A red animated LED, right? So we found red animated LED. So we click OK again. Again, click on P. We'll need a resistor. Definitely, we'll need a resistor because we don't want to interface the LED directly to the microcontroller. This is just a safety feature. So we'll search for a resistor, right? So you'll get a list of resistor again. So we just need a generic resistor, right? We are not specifying any resistor over here. So we just need a generic resistor. So let's just look for a generic resistor. Do we have any generic resistor here? So let's just look for a generic. So can you get it? So yeah, we have a generic resistor. So we have looked up for a generic resistor. So let's edit up here. So just to turn an LED on for 1 second and turn an LED off. So for that particular output, we just need a microcontroller, right? A resistor and an LED, right? So click on the microcontroller to place it on the canvas over here, right? So click on the microcontroller. We'll get the microcontroller on the canvas. Right? There you go. We'll need a LED. So let's get the LED here. Click on the LED. Place the part on the canvas. Again. So just before the LED, we'll need a resistor, isn't it? So let's place a resistor here, right? And let's say we connect this to port B5, right? Now we need to ground the LED in order to complete the circuit, right? Isn't it? So what we do, right click on this, we place a terminal. So it is a ground terminal, isn't it? So right click, place, and go on to terminal and click ground, right? So we have the ground there. We have the ground. Now, the other thing is you can access the same ground by clicking on to the terminals tab over here, right? Just hover it all. Hover on the icons on the left hand side of your screen, right? You'll see that you'll get a selection mode, component mode, all the variety of functions. Just go and look for a terminal mode in order to get the same functionality. So click on the terminal mode, you can get the ground up there, right? So you can click on ground and we can place the ground over here. The other thing is that we can see in the microcontroller there is a master clear over here, that when there is no input, it will be set as master clear. So basically what master clear does is it will reset the microcontroller each time, right? No matter if whatever program you load, it will not run the program. It will always reset the microcontroller. So for that, we'll need a power source, right? So let's click on a power source in order to set this master clear to high, right? And to make the microcontroller perform whatever the program we are going to pass through, we need to supply high input to this particular pin over here. So we'll click on power and we'll place it power over here, right? This is a 5-volt sign, right? So we basically place it over here. Now we can double click on that component and we can set that to VCC, right? And click OK. Now once our circuit is ready, right? This is just a simple circuit. We'll just use this circuit to perform a simple operation of lighting the LED for 1 second and turning off the LED, right? The next thing is to write your program, right? Our circuit is ready, right? Just over here. What we need to do, we need to write our program. So what you need to do, we write our program in our C compiler, isn't it? So the C compiler that we are using is the CCS compiler, right? So just go on your PIC, right? Or the CCS compiler, just click on that, and then we'll just need to write a program. So I have already written the program over here. It is the same program that we had usually written for our microcontroller in our labs or for projects, right? So it is the same program. You can see that you'll need to define the header files, the ICD, and all those stuff, right? We program it as usual, right? So I'm using a red LED, so I have defined it, and I have defined pin D5 as the red LED, right? And then it is a simple operation. I'll write a void main program, right? Void main, while it is true, the LED will be low, turned off for 1 second, and then it will turn on for 1 second, right? And that operation will keep on repeating itself, right? So it is a simple program that is going to turn on your LED on for 1 second and then turn off your LED for 1 second. Be sure what clock you are using. In this particular case, we are using 20 megahertz over here, right? So since we have been familiar with 20 megahertz clock throughout this unit, so we'll keep it at 20 megahertz. So we'll keep it at 20 megahertz and we'll compile this, right? Make sure this is your make file, your project, right? This is your the main project file that we are going to compile because we want to generate a LED. I mean, this is the file name. The file name is led.c. So we'll need to generate a led.hex file, right? We need to generate a hex file for this particular program. So we just compile it. A hex file will be generated at the location where you have saved the program, right? So I have saved it on my desktop, right? So I have saved it on my desktop. So you can see I have the led.hex file over here in the folder where I've saved the led.c file, right? In the same folder, I can generate a led.hex file. Just compile it. So once you have the led.hex file, you go back to your Proteus software, right? Double click on this. Double click on this, you'll see this particular window over here. What you want to do is just look for that hex file. And the program file, click on that small folder icon, you'll get a window, right? And then click on the hex file. So I'm right into that particular folder. If just in case if you're not in that particular folder, what you'll need to do is to look that particular folder and find your LED. I mean that particular program's machine file, right? That is the hex file. Just look for that hex file, click on it, right? So I'm loading that hex file. So I'll click on that hex file and I'll click open, right? Now the hex file is loaded on this particular window. The other thing that I'll need to set is, remember we are using 20 megahertz. So I'll need to reset this processor clock frequency to 20 megahertz. If both of the systems are not in sync, what will happen is your calculation or the time that you are desiring using your program, it will not be matching, right? So I'll set it to 20 megahertz because my program is also already using 20 megahertz. So my processor clock frequency also needs to be at 20 megahertz. I'll set that to 20 megahertz and I'll click OK, right? That is fine. Now what I'll need to do is I have loaded my program. My circuit is fine. I'll need to go to debug mode, right? Click on debug and run simulation, right? You can see the LED turns on and off 1 second. Now, just in case, let me stop the simulation, right? Let me just stop the simulation. Just in case, what happens if you did not change this to 20 megahertz? Let's say if I had kept it to 4 megahertz, right? And I'm using the same machine file that is using a clock of 20 megahertz, right? Now what we are doing is basically we are slowing the processing speed, right? So we are reducing or we are increasing the time, or we are basically reducing the frequency by 5, isn't it? From 20 megahertz, we are reducing to 4 megahertz. So we are reducing the frequency by 5, isn't it? We're reducing the frequency by 5. So what happens to the time? It is inverse, right? So the time delay, we are expecting a time delay of 1 second. So in this particular case, what will happen? We are decreasing the frequency by 5. So the time will increase by 5. Though our program says we'll need to write we will need to generate a 1 second delay. So our frequency will be, our time delay will be increased to 5 seconds. So you can see this, right? I'm changing it to 4 megahertz, right? I'll click OK, and I'll go into debug mode and I'll rerun this simulation, right? So you can see this simulation is being run over here. You can see after 5 seconds, it turns on, and then after another 5 seconds or at 10 seconds, it will turn off, right? Again, it turned off at 10 seconds. Now it is going to turn on at 15 seconds. Now it is going to turn off at 20 seconds. Okay, you can see that, right? There you go. That. So always remember, whatever clock frequency you are using in your program, that same clock frequency has to be set for your microcontroller, right? So I'll stop the program. Remember, our program is using a clock of 20 megahertz. So our processor clock frequency has to be set at 20 megahertz so that the program and the machine is synced together, right? Both of them are operating at the same frequency, right? So I'll set it at 20 megahertz. Again, you can see now I've set it to 20 megahertz. I haven't changed the code. I've just changed the processor frequency. Now remember, my code has a 20 megahertz clock, while the machine is now set at 20 megahertz, and we'll need to generate a 1 second delay. Let's see, are we getting a 1 second delay? At 1 second, it will turn on. At 2 seconds, it will turn off. At 3, on, off, right? So you can see that now we are getting a 1 second delay. So always make sure whatever clock you are using in your program, that same clock is being used as your processor clock. Okay, right? You can see I've set it to processor clock frequency, right? Okay. Now let's try out the interruption. Let's try placing a button, right? Let's see if we click on the button. Right. Let's see if we click on the button, do we get the, are we able to use the button to light up this LED? So in this particular case, we have already interfaced the LED. Now we are going to interface it. button, right? And see whether we are able to use that button to turn the LED on or off, on and off or not, right? So again, we'll go to component mode. Now, what else do we need? Now we'll need a button, isn't it? So we'll click on part and look for a button, right? Let's search for a button. So we get a push button over here, right? So we'll click OK. Now the button is placed over here. Now, let's bring the button over here. Now let's place it over here. Okay. Let's place it over here. We'll need a resistor. Let's place it over here. Rotate it. Okay. Delete this button because I have placed it in the wrong place. Just delete it. So let me just place the resistor first. Place the resistor here. Rotate it. Now let's place the button. Right. We have placed the button. So this has to be connected. Then this is connected. Since we are using an external button, it has to be using a external interrupt, isn't it? So let's connect it to port P because port P has external interrupts, right? Port P0 is external interrupt 0, port P1 is external interrupt 1, port P2 is external interrupt 2, and so forth, right? It's written over here, INT2, INT3, right? So forth, right? So that particular button has that particular characteristics associated with it. Now, this button has to have a power source as well. Right? So what we can do is take this button, okay. Now we just need to connect that wire, this button, to a power source. So in this particular case, we can use the same power source as the VCC, right? Okay, because we are supplying the 5 volt to the button. So whenever the button goes, whenever the button goes high, it will turn on the LED, right? So whenever the button goes high, there will be a power that will be generated to, there will be an input to port P0, right? We'll also need to place a ground over here, right? At the end of this resistor to complete circuitry. So again, click on terminals, ground, click, and place a ground, right? Now our whole circuit is complete again, right? So whenever we press the button, it will generate it. That 5 volt will flow from the button towards the input, right? So we need to set port P0 as our input as well. So again, this code is already given in your lecture slides as well, right? You can use this same code. So what I have done is I have, again, just define all the files, right? All the files, define all the header files, right? So in this particular case, I have to include the header file for this particular microcontroller and the ICT device and the fuses and all the delay clock as usual as a regular, if you were programming a actual hardware, right? You just write the code as it is. No need to change anything, right? So place the header files as usual. And the next step is to write the interrupt code, right? Because we are using an external button. So there needs to be a code associated with the external button, right? Whenever the button goes from low to high, there'll be a function that will be generated in this particular case, right? So like we have decided, whenever the button is pressed, right, it will jump into this external interrupt function. It will turn on the LED for 5 seconds, right? Let's say it will turn on the LED for 5 seconds, right? And then it will go back to the program, right? It will turn the LED for 5 seconds and it will go back to the program, right? So that is basically what happens whenever you press the button, right? So I've defined the function over here. Again, next thing is to define the actual main program. So we have already done this. So I'm just doing it again for this particular purpose. Remember, like I said, the first thing is to clear all the ports, right? So clear all the ports. So this is a particular code line that we are going to use to clear the ports, right? There is output needs to be 0x00, right? So basically setting all the ports to 0, right? Basically setting all the ports as output ports. Then we set port B0 as our input, because at port B0 we have connected this particular button, right? So whenever there is an input from the button, right, it will trigger a interrupt, right? So that is why we are setting port B0 as our input port, right? While all the other ports are output ports. Then remember, we are using an external external pull-up resistor. So in this particular case, there we'll have to disable all the internal pull-ups. So we have disabled all the internal pull-ups. And the external interrupt edge that I'm going to use is from high to low, right? So once I have set up all the external interrupt part, once I have set up all the particular settings for the ports, I'll then define the interrupt configuration, right? That is to enable the external interrupt, enable the global interrupt, and then set the pin, the initial state of that particular port P5. Remember, our port P5 is connected to the LED, right? So in this particular case, I'll set the initial state of the LED as low, or it is turned off, right? So inside this while loop, I have set the LED to be turned off full time, right? So the LED will be off throughout its function. So whenever there is an external interrupt, it will jump back into this void function. In this external interrupt function, it will turn on the LED and wait for 5 seconds. Then after that, it will come back to this particular while loop, right? I could have also placed this output line. I could have placed it in this particular function as well, right? It would have done the same thing, but I have placed it over here, right? For safety reasons, in order to ensure that the LED is off throughout the function. So whenever I press the button, then only it will light up, right? And after that, for 5 seconds, it will go back to off, right? So this is just one way of programming this particular system. You can program it in whatever way you want, right? So this code is basically given in your lecture slides, so you can make this code, right? So again, we are using a 20 megahertz clock. So just make sure your processor clock is also set as 20 megahertz. Again, let me set it to make this file as my main project file, and then I'll compile it so that I can generate a button interrupt.hex file, right? So this is basically a hex file for this particular program. So once I have generated the hex file, what I'll do is go back to my software. Again, I'll click on this. In place of LED hex, I'll change the hex file. It's for the button interrupt, right? I'll load my hex file into this particular microphone. Okay. Ensure your processor clock is set as 20 megahertz again, and I'll press. Now let's test it out. Let's see whether when we press this button, does the LED turn on or not, right? Remember, the external interrupt edge is at the moment set from high to low. So that means when you press the button, nothing will happen. When you release the button, then only the LED will turn on, because the button will go from high to low, isn't it? The button state will go from high to low. So let's run the simulation. Let's see what happens. Nothing is happening, isn't it? When I press the button, nothing happens. When I release it, the LED will turn on. There you see, right? So after 5 seconds, it should turn off. There you go, it turns off. So let's see. Nothing happens. When I press the button, does it light up? Does it light up for 5 seconds? Current simulation time is 20 seconds, right? 20 seconds. It was 20 seconds. Does it turn off at 25? Let's see. There you go. 25 seconds, it turns off, right? So it is working. So only thing is that you need to ensure that you'll write your code as a usual practice that we have been doing throughout this semester. We'll write it in our PIC compiler that we are using. That is the CSS, the CCS program that we are using. So we'll use that to write our C code. We'll compile and generate a hex file. And using the hex file, we'll upload it into the schematics that we draw in the Proteus software, right? So based on that, we just need to upload it on this Proteus software and just make sure, right? Just make sure to upload the hex file into this particular system and set the clock frequency as the clock frequency that you are using in your program as well, right? Always make sure that. The other thing is you can change the values of the resistor. Sorry, I did not change the values of this resistor. You can double click on this resistor and you can change the values. Right? Just go into this component, right? There you go, the component is highlighted now. Double click on it, right? Sorry. Double click on this. Sorry. Just double click on that and you'll see that you can change the resistance value. It should not be 10 kilohertz, 10 kilo, but I had earlier on said it, just left it like that. It should have been close to 1K. That would have been fine because 10K will reduce the amount of current that is coming into circuit, right? So we don't want to do that. So 1K is been fine because the LED operation value is close to around 3.5 or 3.7 volt up till 5.5 volt, right? So we just want to limit that current that is going to the LED, but not that extra. So always try to limit the always try to place a reasonable resistance, right? Again, in this particular case, I should have set it to close to 1K. That would have been fine, but 10K is also fine, right? So that's it for this week's tutorial.